Good afternoon. This is Felix Schmid speaking. I'm introducing this session on behalf of the Railway Division of the IMechE. This is the first virtual event of the IMechE Railway Division, or the first headquarters event. All our events have gone online, and all our rail events have been coordinated across the country. So if you want to look at anything, you should find that they are not running in parallel. They are all nicely running in sequence. And today's event is about rail freight, an introduction to rail freight by Ralph Goldney. Ralph is a fellow of the IMechE. He's also a fellow of the ICE and of the Chartered Institute of Logistics and Transport. He runs a company called Railfreight Consulting. He's got a lot of experience with that company. I think it's been in operation for 11 years now. He's done work on jet fuel to Heathrow, and we'll hear more about that a bit later on. He's worked for Etihad Rail, Lafarge, Cemex, and he's helped London Underground with the rebuilding of its works train fleet. If you have got questions, then there is a button on your screen which you can press and then write a question. We will answer the questions at the end of the session, but you will be able to continue putting up questions all the time. So thank you very much, and I shall now hand over to Ralph for his presentation.
Well, hello everybody, and thank you for joining us today. Move straight on to the aims and agendas. So I'm hoping to provide you with an overview of rail freight for those that aren't familiar with the area. We'll do an engineering bit. We'll look at how rail freight works, the typical loadings. We'll do a commercial bit. We'll look at the market structure, how the various parties in rail freight work together, and how clients can access rail freight services. And we'll do a little bit of stuff on haulage costs and how they're built up. We'll do a little bit of an operational piece, and I've got a case study. I worked, as Felix mentioned, on a new flow of jet fuel to Heathrow, and I've got a little video there that BP developed a training video, and so we'll go through that. And then right at the end, we'll have just a look at the future. And hopefully, provided I don't yammer on for too long, we'll have some time for some questions. So I hope we can get that. I just should say at the beginning that this presentation is written from a UK context, and I'm aware that people are coming in from all over the world. But the general principles apply everywhere else, and I will try to make reference to other railways to point out the differences of the countries as I go through it. Okay, so we're going to start off with just looking at the constraints and the basics of rail freight and how it works. I'll move straight on. So we have here a picture of a lovely little cement wagon that I took at IMechE's facility in Tunstead in Derbyshire. And I just want to go through the engineering basics of how stuff is carried by looking at the wagons. So a modern wagon generally have 4 axles, and you can see that there are 4 little yellow arrows. The first constraint that rail freight has is actually the amount of weight that we're allowed to put into the track. So in the UK, it's generally 24.5 tonne. So with 4 axles, if you just look at the maths, we're allowed a weight of 101.6 tonne. 100-tonne wagons is what we colloquially call, but it's 101.6 tonnes. If we then subtract the tare weight of the wagon, the unloaded weight, we then get what is the available weight for us to carry, which in the UK is around about 75 tonne. So that's just very, very simple maths. I say to people who are just getting their mind around rail freight, hang on to the number of 70. 70 is roughly the payload of over a wagon. I've just said it's 75 ton. If it's fully loaded, it is, but 70 is a good number. And each train generally carries the equivalent of 70 HGVs. If we're talking about bulk loads, they're carrying around 20 ton. So one train is roughly 70 HGVs. So that's a nice number to hang on to. One of the reasons that I put this photograph up is that actually I wanted to make the point that the wagons are very, very heavily optimised for the product that they carry, and they're also very carefully engineered to carry as much payload as they can. So as I said before, this carries cement, which is loaded pneumatically. It's blown on and blown off. And this is a very unusual wagon in that it's got an aluminium tank. So the bit at the top where you've got VTG and Lafarge, that's made out of aluminium. That gives a more expensive wagon to build, but the aluminium tank means that the tear weight of the wagon is reduced by about 3 ton in comparison to a steel tank. So that means that the wagon can carry 3 tons of more product on each journey. And that's a wonderful thing that keeps giving every time the train runs. And so it's very, very much worth paying a little bit more for the wagon to get that kind of value. And wagons are highly optimized. The final thing I should say while we're on the slide, I'm talking about the first constraint, which is the axle weight. In the UK, we call that the route availability. So this is the highest route availability, RA10, that you'll get on the UK network. There are parts of the UK network which have a lower route availability. It can go down to 16 ton. And these tend to be more rural lines or coastal lines where there are very old bridges which can't take these very, very heavy trains. And then we have to do different things. We have to partially fill wagons or stuff like that. But generally in the UK, everywhere is 25.4 tons. And that's the engineering basis of how we move stuff around. Our second constraint is the loading gauge. So this is the physical space occupied by the train. And you can see that there's a cross section there. What's very interesting is in the UK, we have a relatively, in comparison to our continental neighbours, we have a smaller space. That's largely a historical thing to do with the number of Victorian arches that we've got. Their arch structures don't do very well when you're moving square-shaped containers. It's a big deal. So we have a series of different loading gauges in the UK where we can move stuff around. It can get very technical. I'm not going to go much further than that. But it's worth saying that actually on the continent, generally, they have a larger loading gauge, they have a larger space, but they have lower axle loads. Their bridges aren't as strong. So in the continent, in Europe, generally, you have 90-ton wagons, 4 axles at 22.5 ton axle weights, but they can have larger wagons. This is why you actually can often see double-deck trains in the continent, but it's harder to do that in the UK, passenger trains. One consequence of that is it's difficult to exchange wagons between the UK and the continent. If you try and bring Continental wagons over to the UK, they start hitting all the canopies over stations and stuff like that. It doesn't work very well. Whereas if we sent our wagons over there, they're volumetrically too big to be efficient for use. So the first constraint was the route availability, the track weight. The second was the loading gauge, the space. And the third constraint is what we call the track gauge, the distance between rails. By historical accident in the UK, we've ended up at 4 feet 8.5 inches, or 1435 millimeters, a really memorable number, not. This is what is known generally as standard gauge and is used in large parts of the world, but there are different gauges. So standard gauge is used in America, it's used in China, used a lot in Europe. But there are different gauges. So Russian gauge is 1500 millimeters. Iberian gauge, Spain and Portugal, 1600. Large parts of Africa have a 3-foot gauge, 1067. That's all of this is a consequence of what was felt right at the time they were built. It's a very difficult thing to change. But it's worth noting that can cause problems. So one of the developments in rail freight recently has been the development of the Silk Route and freight trains coming over from China. As they cross over to go through Russia, there's a break of gauge. So the Chinese gauge is different to the Russian gauge, and then when you come back from the Russian gauge into the European gauge, there's a change again. And so that has to be managed, and there are various ways that they manage that, but it's worth acknowledging. So that's just a quick jaunt through wagons or the constraints. Then there are very many different types of wagon. So I've written here, all wagons are the same but different. They're all same in that they have the same stuff at the bottom of them. So they have what we call a bogie. So a bogie holds, in modern wagons, it holds 2 axles and it holds a suspension and brake gear. You can see it very clearly in the middle picture at the bottom, where you can see the bogies with those 2 axles underneath the red wagon. So you have the bogie, you have the buffers and the draw chain that pull the train along, and you generally have some kind of structural connection between the bogies called the sole bar, which holds the weight above. So all wagons have that. But then what goes on top of the sole bar depends on the product you're carrying. So at the top left, that's a box wagon used for holding loose spoil. That's a photograph I took at the Crossrail work site at Westbourne Park, where they were taking tunnelling soil. The middle photograph is one of my lovely jet fuel trains, jet fuel wagons at BP's terminal at the Isle of Grain that takes jet fuel to Heathrow. The third wagon on the right-hand side you can't see, but it's actually an intermodal train, and we call them flat wagons, where there is nothing above the sole bar, but we load it directly on. On the left-hand side at the bottom in the centre, there are 2 photographs that are what we call hopper wagons. So these wagons, the left-hand wagon is a coal wagon, the right-hand wagon, the middle wagon is a aggregate wagon. These hopper wagons act like a bathtub. You chuck it in the top, and then it opens at the bottom and goes out into a bottom discharge pit. On the left-hand side, wagon, you can actually see a welding seam on the wagon, which shows the side of the bathtub. What's very interesting is the coal wagon obviously carries coal, which is a very low-density material, 0.8. So to carry 70-odd tons of material, you need a 90 cubic metre bath, which means that wagon is about 19 metres long. The wagon in the middle is an aggregate wagon, which is heavy, 1.4 tons per cube. So therefore, they need about a 55 cube space. So that wagon is only 14.3 metres, that one. You wouldn't want to put aggregate in the coal wagon because you'd end up half filling the wagon, you'd overfill the wagon, which is a disaster, and you'd actually have a very spatially inefficient wagon. So actually that wagon in the centre is an old coal wagon that's no longer needed and has been chopped in. Well, the middle third has effectively been taken out of the wagon and welded back together. And that's because, and we'll come to it later, as the market have changed, we're no longer pulling coal, but we're pulling a lot more aggregate. And actually, it's cheaper to repurpose coal wagons because the bogies are very expensive and the draw gear is very expensive. And so that's what we do, and we repurpose them as aggregate wagons. Ultimate recycling. The photo on the bottom right is larger, not only because I thought it would look nicer, but actually it's actually a physically larger wagon. This is a wagon for carrying sulphur, and I took this when I was working in the UAE, and it's actually got a 30-ton axle weight. So this is a freight-only railway. They deliberately decided, very reasonably, to make structures a bit stronger so they can have higher axle weights, and that wagon is 120-ton gross, carry about 100-ton, 95-ton of sulphur per wagon, so you get a lot more per train. So, as you can see, all wagons are the same, but are slightly different. They are commodity specific, which is really important. If we now talk about locomotives, it's a bit easier to talk about locomotives. Locomotives generally are 3 types. So we have ubiquitous diesels, which kind of go anywhere and are around 95% of the haulage. So top left are the Class 66 locomotives, which are by far and away the most common locomotive we have in the UK, around 450 in service. On the right-hand side, there's a slightly more modern Class 70. They have got about 3,500 ton horsepower, 2.5 megawatt, very powerful and can move most stuff. Bottom right, we have two electric locos. We have a Class 92 and a Class 90. They are more powerful, considerably more powerful. They are carbon friendly, however, they need the wires. And actually, that's often a problem with rail freight because we end up going to terminals that are in the middle of nowhere, that aren't electrified. Actually, when you're in the terminal, you don't want electrification overhead because it's dangerous, all that kind of stuff. But actually, they do have a place on certain routes. You can think of an electric locomotive basically as a mobile transformer. They pick up the power from the catenary above and convert it to power to apply to the traction motors. More recently, we've seen the movement to developing hybrid locomotives. The bottom left-hand photograph is a Class 88 locomotive, which is primarily an electric locomotive. It's a 4 megawatt electric locomotive. But it also has a small diesel engine on it, 1 megawatt diesel engine on it, which allows the final mile to be delivered where by the train, by the locomotive, where there isn't catenary available. That's really, really great. However, it's a very expensive locomotive. So that's locomotives. So let's now just get our business head on and have a look at the rail freight market. We'll look at what's being carried, what's happening to the market in the UK. We'll look at how that's affecting the geography of what's happening. So the following figures I'm quoting are from the UK rail regulator, the Office of Road and Rail. They have a really good data portal website where all this stuff I've stolen from. And if you want to look at this in more detail, you can really have a great day going through all this kind of stuff. This little chart shows what is being carried, and you can see that the largest sector is intermodal, domestic intermodal as opposed to channel tunnel intermodal, which is very small. The domestic intermodal has two parts to it. It's what we call deep sea. So these are containers that are landed primarily at Felixstowe, Southampton, Gateway, T-Sport, and are then moved into the centre of the country or for distribution to the retailers. Very, very important sector. A second sector is what we call domestic intermodal, true domestic intermodal, and this is largely what we would call the supermarket trains. So a lot of the retailers now have got on board with Anglo-Scottish flows from Daventry and places like that up to the central belt of Scotland and beyond, where the supermarkets have found that it meets their supply chain requirements very, very well to put stuff on trains, deliver it overnight, and it's been very, very successful. I now think that 25% of the containers going into Scotland are delivered by rail. And this is the Tesco train, the Stobbart train, Asda, Sainsbury's. They're all on it, and it's great. And it's been a real growth area. So that's intermodal, think containers. That's what we're seeing here. Construction is just this. So it's bulk materials for the production of concrete. So this is aggregate and sand and cement. And also for the construction of roads, a lot of stone comes down. And also for major construction projects, particularly tunnelling projects, it's a lot of removing the tunnelling spoil. I'll talk more about this. Metals is scrap metals. Oil and petroleum are various types of fuel, both jet but also ground fuel, a little bit of international, other can be all kinds of stuff. Very interestingly, one of the commodities we move is cars. One of probably the most valuable trains in terms of commodities is the train that comes down for Jaguar or Land Rover Jaguar from the Midlands to Southampton. carrying about 60 or 70, £100,000 Range Rovers on it. That's a lot of value. Outside of this block, there is another block that the ORR don't measure because it's internal, and that's for Network Rail. Network Rail are the single largest client of rail freight services in the country, with around 35% of the market. They buy freight trains for their own purposes. They are not able to run trains. They are an infrastructure manager. I'll talk about that later. They need trains for many purposes. They need trains at the weekend to renew the network, and also on larger blockades to undertake enhancements. These trains run from local logistics centres. They've got an array of them across the country. And so there's a second requirement for trains to move from the quarries and the sleeper production facilities to put the materials into these distribution centres in the first place. Network Rail also run a number of seasonal trains. Around this time of year, they run works trains to control vegetation. Later in the year, they'll do what we call railhead treatment trains, where they'll come and blast a load of sticky stuff on the rail to improve railhead adhesion to stop trains skidding through. And later in the winter, they may even use trains for snow and ice. They also have trains, freight trains, or modified freight trains that they run, or modified passenger trains, to undertake track recording. Network Rail have got a very, very sophisticated fleet of trains that can record the state of the rail and the ballast in real time. And they're a very, very important client outside of this mix. So if we just look at at what's happening in the marketplace, this ORR chart shows the billion net ton kilometres haulage over a 30-year period, which is very interesting. So rail privatisation, freight privatisation was in the late 90s, and we all thought it was going swimmingly well until about 10 years ago or 5 years ago, when you can see from the peak there's been about 27% reduction, and I'll talk more about that now. It's worth saying that in the UK, about 9% of total freight is moved by rail. That's, by international comparators, relatively small. It's 20% in Germany, and I believe up to 40% in America. And that's a lot to do with our geography. We are a relatively small country, and also to do with the fact that actually we have primarily a passenger network, and it's harder for us to get the routes and the capacity that we need. In America, obviously freight, which is a much higher proportion, is their primary use. So that's the market, and you can see over the last few years it's gone down by about 27%. If we look at that a bit more detail, I need to explain this line. So the dark blue line is the total volume over the last 15 years. The grey line in the middle, if we just focus on that, that's everything else but coal, and the light blue line is coal. And so what's happened to rail freight is that our biggest commodity, which was at one stage 40% of our market, has basically stopped. And I've included an extract from the BBC News website to explain why that is, and it's very obvious when you think about it. We're no longer burning coal in our power stations. It's more or less, all of the coal power stations are more or less closed. And with that has become a massive reduction in the amount of coal that has been moved. And so this is why in the previous slide I showed you a coal wagon that had been repurposed as an aggregate wagon, because aggregate is doing very well, and so that's what's happening. So that's led to some other changes. So the next slide, there's two different things going on here. First of all, if you look at the left-hand side, Tarmac are one of my best clients, and this shows their network of railheads. This explains how the construction market works, which simplistically consists of bringing suitable material to the southeast to build stuff. The southeast of the UK is chalk, clay, and these materials are not suitable for building concrete or building roads. You need limestone principally, and you need cement. And there are no local production facilities for that. So every day, thousands of tons of material are brought from Somerset or from Derbyshire, places like that, into London on freight trains. This has been a growth market, and so there are a lot more trains coming to the southeast. At the same time, the other growth market for rail freight has been the deep sea intermodal, and I've put 3 stars on that little mark on the little map that shows Southampton, Felixstowe, and Gateway. So again, more demand in the southeast. However, historically, rail freight's been something that happened in the north. Coal was produced in the north. The power stations were put in the north because that's where the coal was. Steelworks were there. Rail freight happened in the north. So what's happened is that not only has the absolute scale of the market changed and the volumes have changed, but also the centre of gravity has changed for the market. Rather than being something that happened in the north, it's now much more become southeast. That's created an additional challenge for the rail freight hauliers, the freight operating companies, in that actually their people were in the wrong place. So you may well have a driver who's based at Doncaster who's spent his life moving coal to the power stations. And now suddenly you need to say to that individual, would you please move down to Wembley so we can use you to move construction materials into London? That's a difficult conversation to have. And one of the issues that we've had over the last few years is a shortage of drivers in the southeast for these reasons. So I'm giving you a picture of the changes that have happened in the rail freight market. Another change is that actually the absolute number of trains that have run has reduced. This is because trains have got longer. The absolute number of trains has reduced by about 50%. So we've seen a 27% reduction in trains, but actually we've seen a 50% reduction in freight trains. And that's because we're getting longer trains running more effectively. Okay, moving on. We'll just talk about who's who in the market. So we'll talk about the path to privatisation. British Rail was privatised in the in the late 1990s. It was privatised in 6 lots, and those 6 lots are shown on the next slide. 5 of those lots were consolidated into a company that became known as EWS. They actually pulled together a lot of the other businesses and consolidated those markets. So for quite a long time, there's a duopoly operating where Freightliner and EWS were competing. Freightliner were the intermodal part of the business. More recently, there have been other organisations that have come into the sector. So GB Railfreight have been very, very effective in entering the market. And there's the Direct Rail Services that operate nuclear equipment. And then there are 2 or 3 other smaller organisations. So what's happened now is that we've got a much more competitive market with lots of other people. And it's actually great for clients. We have a very competitive market and there are choices. And so when I run tender competitions for people, I can say to them, there are a number of organisations that can meet your needs. It's worth saying that these businesses are known as freight operating companies, FOCs, and that's opposed to train operating companies, TOCs, that run the passenger trains. So on the network, we have TOCs and FOCs. Okay, so just looking at the market share of these organisations, so as I've explained, DB Cargo, I should have said, DB Cargo, the old EWS organisation was bought by Deutsche Bahn in 2007, the German State Railway, and is now known as DB Cargo. So DB Cargo had around 80% of the market share, and it's actually gradually losing some of that market share, and is now around 40% of the market share. Freightliner has about 30% of the market share. GB Railfreight is the other major player. Colas is, these are ORR figures. Colas is reported separately because it's a subsidiary part of another railway body. They have around 5% of the market share. And DRS, with their nuclear business, have around 10%. So you can see that the market has 3 or 4 major players. And the turnover of these businesses is around £800 to £900 million between them. You can see it's bounced around a little bit over the last few years, but it's of that order. And what's also quite interesting is that these businesses, it's tough. So these 4 major businesses you can see are not making huge amounts of money. With the exception of DB Cargo in 2014, 2015, when they made an exceptional profit around a property transaction, you can see that the numbers in absolute terms are not massive in terms of margin on their turnover. I actually feel that the freight operating companies are very similar to construction companies. They have relatively low margin businesses, but they have a low asset base as well. So actually they can get a very reasonable return on capital employed. But I reiterate the point, it's a very competitive marketplace. And I've seen that with my clients. These guys are competing on quality and price, and actually that's driving train length extension because that's more efficient. And actually it's been a very, very positive thing for end users. We're getting very, very good haulage prices, very competitive. If I just talk about the wider industry now, we look at how all of these organisations work together. On the left-hand side, we have the customers that have goods to move. In the centre, we have the freight operating companies, who, together with wagon leasers, who provide the wagons, some of the FOCs have their own wagons. Most wagons these days are leased from third-party organisations. The freight operating companies move the stuff. They use the network provided by Network Rail. So Network Rail are what are known as the infrastructure manager, with an operate, maintain and renew, OMR, mandate. Okay, so Network Rail provide the rails, the freight operating companies move the stuff around for the customers. Sometimes customers will go to a third party, a logistics provider, to help them with their rail freight. This is particularly prevalent in the intermodal sector, where customers have road-based networks they're moving on to rail, or they've outsourced their logistics functions. So now there are very capable organisations like Maritime and Malcolm's, Stobart's that are moving into this space, offering a total transport solution where they will actually provide rail freight as part of it. Those organisations are not freight operating companies. Freight operating companies need to be licensed to run by the ORR, but they buy capacity off the freight operating companies. Sometimes they contract them to provide specific trains for them. On top of all this are the government bodies. You've got the Department of Transport, the Scottish Assembly, Scottish Executive, Welsh Assembly, setting policy, deciding where to invest in the railway, providing grant support. The intermodal traffic is underpinned by grant support. You have the Office of Road and Rail, the rail regulator, that actually manage Network Rail, but also license the freight operating companies. They are the safety organisation. The Rail Safe Standard and Safety Bureau, that actually set the rules by which the railway runs, and the Rail Accident and Investigation Body that finds out what's going on when stuff goes wrong. So that's the UK model, but it's actually worth saying that this is a European model. This separation of the infrastructure manager, Network Rail, and the freight operating companies, FOCs, and the train operating companies is a model that's been mandated by the Europeans, particularly around freight, where they wanted to improve the competitiveness of the freight industry in countries where the only freight choices you had were to go to the freight subsidiary of the national railway. Now, the UK is kind of the most devolved model. We've completely privatised the old British rail freight network. We've now got a very, very competitive network. In most of the European railways, the national railway still has a freight subsidiary, which operates at arm's length. So SNCF have a facility, DB do as well, and they compete with new starts. So that's industry structure, really. I guess that's what I'm saying. Okay, so we've talked about that. Let's talk about money, because it's easy to forget this. It's kind of really important. So there's a graph here that shows the price per tonne for various payloads. And so take all of this with a pinch of salt. Every flow is specific. But this shows that to move a tonne of material can vary between £9 a tonne and £2 a tonne. What it's dependent on is the distance that you travel and the payload of the train. And the payload of the train is basically related to the number of wagons behind the train, and that's largely dependent on any length restrictions, either at terminals or loops as you go through the network, and also whether there are any severe gradients that you have to go over. Bizarrely, for trains going north out of London, there's a very severe gradient on a freight network as you come north of Clapham Junction. You wouldn't think there are any hills in London, but actually there is a very severe gradient which constrains the length of trains to 18 or 20 wagons in that particular area. Now, these prices are based on a fully utilised set, a train set working efficiently every day. And so you need a lot of stuff to get these kind of costs. But where this volume exists, prices by rail are much cheaper than prices by road. So I did some work on Crossrail. We were able to move 1 million tonnes of material, which is just a number, but it's 5 trains a day. 350, the equivalent of 350 HGVs from Westbourne Park near Paddington over to Northfleet. And we were able to take all those lorries off the road, and the cost per tonne was less than a cup of coffee. We moved 1 million tonnes for less than £3 million. It was absolutely nothing for Crossrail, and we took 350 return HGVs off the roads every day. Spectacular benefit, but you don't see, and it shows just how effective rail freight can be. I just put a cost model that I've developed to give you some idea of what the typical cost constituents are. Now, this is a flow of petroleum, ground fuel, from Immingham, which is Humberside, down to southwest to Wiltshire. The left-hand side is the input column. That shows that this train has 24 wagons behind it. They're petroleum tanks. Each tank has 75 tonnes of product on it, and it's going about 225 miles each way. This then works out at the top right, the weight of the train. The loaded train weight is 2,500 tonnes. It's carrying 1,800 tonnes of product. And at the bottom right, it tells you it's £5.55 a tonne. That's the haulage price for the return journey. What I wanted to share with you, the indicative cost constituents of that. So, locomotives, the traction cost is about 6%, the wagons are 8%. Track access, which is the money that the freight operating companies have to pay Network Rail, which represents the damage, that notionally represents the damage that the wagons cause to the track. That's 15%. Fuel's 25%, labour's 24%, and you've got overhead and profit on top of that. Now, this is a relatively long flow, 225 miles from one end of the country or not to the others. But actually, you can see where the costs come from. I talk about roughly 10% being the locomotive, 10% being the wagons, fuel around 20%. So you can see what drives this. It's interesting when you see this, actually. For rail freight, it's important to recognise that fuel is around 20 to 25% of our total cost, Whereas when you're competing with road, their fuel costs are around about 50%. So generally, a high fuel price will drive business to rail. Rail becomes more competitive because it's a smaller percentage of our total cost. Okay, I hope you find that interesting. So now I'm just going to pull this together in a little case study. I worked for several years developing a new flow of jet fuel to Heathrow for British Airways and for BP. And last year we were fortunate enough to win the National Rail Awards Freight Logistics Prize. As part of that, I won't say too much about it because it's in the presentation, but BP developed a training presentation for their staff, and they very generously given me permission to share that video. So let's hope it works. So here we go. I'm going to let this run. It's a 5-minute presentation. It deliberately doesn't have a soundtrack. So you've got me. So 16 trains a week with 20 wagons. So this is this length constraint that I talked about. Trains are often longer. And delivering 1 million tonnes, around 20% of the airport's need. Providing greater resilience. So we worked out it was taking off about 120 HGVs off the M25 every day. That's return movements, significant benefit. So this is the route from Colnbrook, where was the pipeline, through West London, crossing the Thames at Chelsea, running underneath Clapham Junction, and then running out into the Badlands of Kent. So there's a 13-mile freight line from Hoo Junction out to the Isle of Grain, where the import terminal for BP is. So this is the Isle of Grain, where that's BP. All of this used to be BP's, but now over time it's different users. So this is the train movement. Sorry, we just did describing the site first. There's various gates. And this is the unloading. So there's a road crossing here. And then we have some reception sidings. So we see Freightliner here. This is because BP cleared to demonstrate to their people that Freightliner are operating the points. Freightliner were the haulier for this service. So we have 2 loading roads, fuel 1 and 2, and 2 stabling roads, sidings 3 and 4. We have an outer area where we can fuel and maintain the wagons. So here's our train arriving. It's a green locomotive, so it must be Freightliner. There it is. And there are the VTG, the wagon leasers, wagons. And that's the road crossing. We open the crossing. It's open for 3 minutes. The train doesn't stop. That's just the animation. It runs through. We have to pop over the next road crossing because we're so long. We change the set of points behind the train, and then we push back, propel the train onto the loads. These are empty wagons arriving to be loaded again. So the train pushes back, half on one side, split the train, half on the other side. Take the loco out so it's all nice and safe. And then we load the train. Wonderful. So the train's loaded, the locomotive comes back, grabs hold of half, and sticks it back on top of the second half. Freightliner operating the points. BP are opening the gates electronically. The train now does what's called a run round. It has to get the locomotive on the other end because the locomotive has to be at the end of the train. It just pushes back to clear the road junction. And then the locomotive does this run round. Great advantage of modern locomotives. They have a double cab. The old steam engines, you're always turning the locomotive to point in the right direction. And now she's on her way back to Heathrow, carrying 1,900 tons, 1,500 tons of fuel. Back she goes. One of the great problems with this flow was actually we have to interface with a number of different passenger services. So you go from South Eastern to Southern, West London line and onto the Great Western. Each one of those things, getting paths so you get your train through, was a significant challenge. And Network Rail were very supportive. So here's Conbrook, the Total terminal. Locomotive comes in. It's able to accommodate a 20-wagon train. They extended the infrastructure so we could do that. Locomotive runs around, out of the way. The gates close. Oh, that's strange. The seems to have frozen. Ooh, so for some reason it seems to have frozen. But anyway, the gates close, and basically the product gets pumped into the Heathrow system. So that shows you just how the train movements work. And generally we're doing 2 to 3 trains. The intention was to do 3 trains, to have 2 sets of wagons doing 3 trains every 2 days. So we're delivering 3 loads a day. So that's been very successful until COVID and airlines, and it's all gone wrong. But I hope you found that interesting to see how that works. So future developments, well, I guess more of the same. Railfreight works really well for heavy stuff, and so it will continue to do that. Intermodal will continue to go. Biomass is a new product that we're moving. On the right-hand side, there are some biomass wagons. They're hopper wagons. Replacing coal with biomass is great for Railfreight because it's got 2/3 density and 2/3 calorific content. So for the same amount of power, you need 1.5 times more trains per gigawatt of power. Construction is going to continue to go. New markets, well, we might get some international intermodal. I mean, we've got some of that at the moment, but it's not really working very well. We might get some international high speed. Another area where we think there could be some significant growth is more domestic trains, high speed trains for either supermarkets or logistics. So there's a little photograph there, the Royal Mail train, which bangs up and down the West Coast Main Line, taking mail from London to Warrington and then up to Scotland. We could start seeing more of that. People like various people we can imagine coming into this kind of high-speed logistics. And similarly, we could start doing the same sort of thing into city centres, where we're moving into stations overnight, doing final mile deliveries by electric vehicles would be great. Or we might start seeing, there's a little photograph on the right-hand side of a concept of very short intermodal trains where we're taking 3 or 4 containers at higher speeds in a smaller way. So some different sectors coming on. Right, I think, wow, that was good luck. We've arrived with 10 minutes to go. So I think I'll hand over to Felix to see if there are any questions. Are you there, Felix? Can you hear me, Felix?
Sorry, I'm here now.
Okay.
Can you hear me?
Can,
so I'm sorry. Yes, I had a problem with the microphone. So there's a lot of questions, and I'll try and take some of those together. So the first one is about loading gauge. Should we try to have as much W12, which is the largest gauge we can get in the UK, or can we work with W10 on a lot of the network?
I think the simple answer to that is we can work with W10 on a lot of it. W12 is very expensive to achieve, but for certain routes it's really important. So routes to and from ports to distribution centres, it's really, really important. But not everywhere needs to be W12. It needs to be just as appropriate. What's interesting actually is to gain the gauge. Often the easiest way to do it is to, rather than change the bridges, is to lower the track. That can be very, very effective at getting gauge enhancements.
Slight problem, of course, with the drainage when that happens. Several people asked about your slide with the percentages, whether these were in the number of tons taken onto a train or whether it was in ton kilometers. Ton kilometers being the ton times the distance it is moved.
So the prices that I talk about are the prices they're prices per ton. So the haulage price from A to B. So that little cost model had a £5.55 price. Those percentages are the constituents of that £5.
Sorry, slight misunderstanding. It's the percentages of the goods moved.
Oh, I see. It's ton miles, I think.
Ton miles.
Actually, yeah. And network, the ORR do it both ways, but I think they're ton miles.
Yeah, okay. And then there was also a question about your graph with the increasing cost per distance, and somebody asked why there was a kink in those lines.
Yeah, and that's because you get to a certain point where you go beyond the distance that one man can do the train on his own. So if a driver notionally will do a 12-hour shift, so if you're going 4 hours somewhere, then there's a 2-hour terminal, let's go 5 hours of 2-hour terminal time, 5 hours back for an intermodal train, you can do that in a shift. If you go over that threshold, then suddenly you need additional manpower and the price goes up, that sort of thing.
Okay. Then there was a question about the loading gauges, axle loads, and whether those were the reason why the UK was not, or rather Britain was not very interested in the new Silk Road long distance traffic from China. But I think I can probably answer that with, we can get trains as far as Barking with the large vehicles and heavy vehicles, but we can't get them beyond that. Is that correct?
There you go, Felix. You know more about Railfreight than you thought. Absolutely right.
Okay. Then there were a couple of questions about innovation and cost of innovation. Kevin Blackdock and Esme Fowler were mentioning that how will freight operators pay for new technology, what new technology is available, and particularly for decarbonisation. There was also a question about having hydrogen on the locomotives in order not to have to use diesel.
Yeah, that's a really good question, and innovation is a really difficult thing on the railways. I did a presentation a few years ago, basically saying there wasn't very much, and if you compared the way we deliver rail freight compared to the Americans driving drones from the other side of the world, it's quite something else. I think what's a particular problem is that the freight operating companies don't have a huge amount of money themselves to invest in this area, and so change has been incremental. We're beginning to see some new types of locomotives, but that's been tough. And one of the realities is that when we come to decarbonisation, clients don't want to pay for it, or not so much they don't want to pay for it, but they can't pay for it. So if you're a supermarket and you're interested in decarbonisation, it's difficult to take a big step to increase the costs in your supply chain by maybe employing a hybrid locomotive than a diesel locomotive, which might increase your haulage costs by 4 or 5% because it's a more expensive locomotive, when your competitors aren't doing the same thing. And so it's really, really difficult. I think in terms of decarbonisation, I think electric's the way forward. Hydrogen has potential. The issue with hydrogen is that actually you need to carry a lot of hydrogen with you, and so that can have very significant effects on the amount of wagons that you're carrying, and therefore the payload on the train, and that's a significant disbenefit. Honestly, every wagon counts, and when you have to give up one wagon or maybe two wagons to carry your fuel, which could well be the case with hydrogen, it's a significant disadvantage.
I think there was also a question about whether electric haulage will actually reduce the fuel costs significantly, which at the moment very few freight trains are run electrically.
So, yes, it does produce a fuel cost. Actually, that's a question of what Network Rail choose to charge. So they have a thing called EC4T, electric current for traction, and generally that's cheaper. Actually, if the government wanted to push rail freight and make it cheaper, one of the ways they could do this is by giving grants in this area or instructing Network Rail to have a cheaper EC4T charge, or reducing the track access charge for electrically pulled locomotives. That would really, really help, and the government does have some direct levers there.
Okay. There was a comment from a member of the audience who happens to be my brother, who said, of course, diesel locomotives, it's the power of the diesel engine on electric locomotives, is the power at the rail, which I think is a fair point. Well,
actually, Felix, it's not. It's a bit more complicated than that. Diesel locomotives are actually diesel electric. So diesel locomotives have a big engine which drives a generator, which then has a sense power to electric traction motors. And so actually, it's the traction motors that you need to look at. But I didn't go into that. It's complicated.
Yeah. Then an interesting question from Switzerland. Labour cost being 24%. Do you think there is any opportunity for using ATO to reduce that cost? Automatic train operation, that is.
Yes, I think is the short answer. Yes, I think that it's a significant step, though. There's some practical reasons. So there are locomotives that you can drive remotely in the yard, and that's the first step. So certainly some of my construction clients, we're talking about maybe looking at that, so that the guy who's shunting can also move the train. I think when you go out onto the main line, there's a lot of safety concerns, and there will be some big industrial relation barriers as well. But yes, definitely. And indeed, in Australia, they've started doing that. They have non-manned trains with very heavy 15,000, 20,000 ton iron ore trains.
Yeah, there's also some automatic freight trains in Germany, small experiments, but they are actually happening near Volkswagen works at Wolfsburg. Then a very, very long question from Paul Baker, but the real question is very short. How quickly can Network Rail react to new flows? Is this a major problem?
Network Rail are very supportive of freight, so let's get that out there straight away. They really, really are. Network Rail are constrained by the passenger network, and so it's about finding the paths, and they will do what they can. But actually, you can't move passenger trains much. And one of the significant challenges that Railfreight has is the increasing number of passenger services. A lot of the metropolitan mayors want to have a turn up and go passenger service where you're moving from 4 trains an hour to 6 trains per hour. And that's really great for passengers, but it's a disaster for freight where you've got loads of passenger trains that are half full, killing the network capacity. That's a political question around the relative merits of passenger and freight trains.
There's a hell of a lot more questions, and they're very interesting ones. but unfortunately we are running out of time. However, I think, Ralph, you have agreed to answer those questions, or at least some of the questions offline, and the answers may well be published. So there should be some good feedback later on. So I think at that point you want to say a few more words, and then I'll close off.
No, I'm done, Felix. Thank you. People can get in contact with me if they like. My email address is there, and I'm on LinkedIn. But that's it for me. I hope you found it interesting.
Thank you very much, Ralph. I think it's a very interesting topic, and it shows that although there are low margins, people do want to use rail, and people do want to produce traffic on the rails for freight. There are lots of challenges, but if we do the job right, I think the future will look bright. Even without coal, there's lots of other things which are waiting to be carried by rail, thanks to the inherent advantages of the long distances at relatively high speed, the much lower labor cost on large flows. So thank you very much, everybody, for attending this presentation. If you have enjoyed it, join other IMechE lectures. It's fantastic to have a large audience, and it's fantastic to get the message across that rail is successful, and hopefully after the pandemic is more or less over, we will see a more environmentally sound freight transport network in the UK. So thank you very much, Ralph. Thank you very much, Natalie, for doing the behind the scenes work. And thank you to the audience for joining us. Thank you to all the people who asked questions. And as I said, Ralph will be able to answer those later on. So thank you very much, Natalie.